US Physics Olympiad year 2021 USAPHO final round. This year all competition was held in one day. There were given 3 big problems with many questions, so it was given 5 hours for all day. If you need more interesting problems, just subscribe for this channel. Problem 1. The jet stream. The jet stream is an eastward with a current that moves over the continental United States at an altitude of 23 to 35,000 feet. The range of typical cruising altitudes of commercial airlines. This strong current affects the flight times significantly. Flights traveling eastward fly significantly faster than flights traveling westward. This problem consists of 2 independent parts. In the first part, you will consider a simple model for airplane flight. In the second part, you will determine the jet stream speed on a fictitious planet called Orb. Part 1. The power that a plane expends is used both to combat drag and to generate lift. Throughout this part of the problem, you may assume that the plane travels without horizontal velocity v-rel relative to the air. The density of air is rho air. The mass of the plane is m, and the cross-sectional area of the plane is ACS. Question A. The drag force on an airplane is given by F drag equal -1/2 CD rho air ACS multiplied by absolute value for v-rel and multiplied by vector v-rel, where CD is the drag coefficient, which depends on the shape of the plane. Write an expression for the power expended by the airplane to combat the drag force from the air. Question B. Airplanes generate lift by deflecting air downward. 1. Estimate the air mass per unit time which is deflected by the wings of the plane. 2. Estimate the power expended by the plane for lift. Question C. Estimate the speed at which an airplane flies relative to the air by minimizing the power expended by the plane. To get a numeric answer, you may use the following parameters. Mass of plane approximately 8 by 10 power 4 kilograms. Raw air is about 1 kilogram per cubic meter. CD about 10 power -2. ACS is about 100 square meters. Next, we estimate the jet stream speed using flight times. Because the jet stream speed on Earth varies greatly with the location, time of year, and climate effects such as El Niño and La Niña, you will instead consider the fictitious planet Orb, where the jet stream is eastward and uniform in the region of interest. At the end of the problem is a map of the region, whose area is much smaller than the surface area of Orb. It means you can neglect the curvature of Orb. Part 2. At cruising altitude, we assume all airplanes travel at a fixed speed v-rel relative to the air. This is not necessarily the same as your answer to Part 1 Question C, which was just a rough estimate. Additionally, we assume that flights occur in 3 stages. First, taxi and takeoff. Second, flight at a cruising altitude. Third, landing and taxi, and that Stage 1 and 3 take a fixed total time t0 for every flight. Question A. Suppose a plane at a cruising altitude is traveling at an angle theta away from due east relative to the ground. What is the speed of the plane relative to the ground? Give your answer in terms of v real, theta, and vw, the speed of the jet stream relative to the Earth's surface. Question B. If the plane travels a distance d, what is the total travel time t, including taxi, takeoff, and landing? Question C. Below we present some data on airplane flights on planet Earth. Each of the flight times shown below has an independent uncertainty of delta t equal 5 minutes. From the data and the map, determine VW and VREL, giving your answer in kilometers per hour with the uncertainties. Indicate clearly what two quantities you are plotting against each other on each graph that you plot. These are data and a sheet to work with this problem.